They're just made up of real numbers, okay? The complex part got cleared away, okay? So that's cool, and we're gonna end up using that later. So anyhow, let's go do our FOIL. Z1 times Z1 is Z1 squared. Next, Z1 times negative Z2I. Negative Z1 times Z2I. Now we'll do this. I'll just write it as negative Z1 times Z2I. Look, everything's being multiplied within this little chunk. Z1 times Z2 times I. When we multiply things, it doesn't matter the order, right? And then lastly,
Why is it negative?
should it be positive? Oh, it should totally be positive. Thank you. And then lastly, look, we'll multiply the two imaginary parts. So negative Z2 squared times I squared. And then we'll take care of that I squared later. Okay, I'm so glad you noticed that this was a positive, not a negative. So look, these are like terms and they cancel each other out. So this and this cancel each other out. Z1 squared. Look, negative times -1 becomes positive Z2 squared. I mean, in theory, guys, yeah, notice that by multiplying, like if you have a complex number and instead of, you take the opposite sign, if this is plus, you make the other one negative. By multiplying those two complex numbers, you eliminate, you get rid of the imaginary part. And I mean, it could be, if you remember this, it can be a fast way. Instead of expanding and showing this middle step, you can just jump to the final answer. But there's nothing wrong with doing the middle step, okay? It will take up a little bit more time, but it shouldn't be a problem. Okay, very good. When we okay, so now we dealt with adding, which is the same thing as subtracting complex numbers. We just saw what it's like to multiply two complex numbers, and now we want to talk about dividing two complex numbers. Okay, so look, here's the example that they give us. Complex number 3 plus 4i. This line means divided by the complex number in the denominator. When you have a division of complex numbers, here's what you do, guys. Okay. Let me just write it here because it's a little clearer. Divided by -3 plus 8i. What to do here is you want to multiply. You can put brackets around both of the numerator and denominator for starters. Multiply the top and bottom by, it's sort of called like the conjugate, just like you do when you're trying to get rid of radical signs. So see how in the denominator we have -3 plus 8i? I'm going to multiply top and bottom, -3, not plus, the opposite sign, minus 8i. If I multiply the top and the denominator by this, in essence, I'm just multiplying by 1, right? Because this would cross out to give me 1. Okay, so then you do your FOIL. FOIL on top, FOIL on the bottom. If you're able to, you can, the fast way is that you do this time, sorry, you do the denominator squared. So -3 squared is just 9. Yeah. And then you do plus, it always becomes plus, and then 8 times 8 is 64. Okay, that's the fast way. But look, there's no, guys, you don't have to stress about that. You can just FOIL the denominator if you don't want to take a chance and do it the fast way. Anyways, I did it the fast way. Then we FOIL the top. And well, we might as well do it. Come, let's do it together. So 3 times -3 is -9. 3 times -8i is -24i. Catch my mistakes, guys. 4i times -3 is -12i. And then 4i times -8i. Let's do that the fast way. It's -32 times -1. So can I just write +32? Make that line longer. Clean this up a little bit. Equals -9 plus 32. -9 plus 32 is, I'm assuming 23. I'm not going to even do the calculation. -24 minus 12 That's negative 36i all over 73.
Wait, when you multiply
Yeah.
the red fraction, why is it minus AI, not plus AI?
Because I probably made the same mistake. Oh, hold on a sec, hold on. Can you circle what you're talking about? Oh, why isn't it plus?
Yeah.
Do you see how what I'm showing you here is a plus? In the denominator, the original question has a plus. You have to multiply by the conjugate that has the opposite sign. So that's why I made it a negative.
Then why isn't the 3 negative?
Only this middle sign has to change. If it's plus, it becomes minus. Everything else stays the same, okay? Like, so the negative 3 stayed the same. Yeah? And then they broke it up into two parts. So for example, if you have, let's just do a quick other question. 6 plus 5i divided by 2 minus 7i. So that's a division question, right? Complex number divided by complex number. Tell me, what would you multiply? Or you can even write it yourself. What would you multiply top and bottom by in order to do this division? You can tell me or you can write it, doesn't matter. So look at this. And the only thing that changes is the sign in the middle, okay? So we would write 2 the way it is, and then we're going to put a plus 7i, 2 plus 7i. Okay, it's nice to do brackets. The brackets remind you to use FOIL, okay? Let's do another one. 5 minus 3i over negative 2 minus, or we'll make it a plus again, plus 7i. What would you multiply top and bottom by in order to do the division and get rid of the imaginary part in the denominator? Does someone want to write it? Just put the answer, what you're multiplying by, top and bottom. Thanks, Mia. Yeah, so this stayed the same. This sign changes. That's the only thing that changes. It became a negative. Is that okay? Did that answer your question? Yeah, okay, good. Very good. Oh, fun, everybody. Do this one. Take your time, do it right so that you get the answer correct. It's division. It's division of complex numbers. So you're going to have to multiply both numerator and denominator by, I don't know what it's called, but it's something like the conjugate. I'm going to write the question over here. They just had to introduce fractions, didn't they? Like, without giving you a chance to even do the easy versions, they throw in some fractions. But that's what probably makes you guys really good math students. You can handle that. Okay, you guys get started on your paper. On the side here, you can tell me what you get as a final answer.